Okay, so members, let us see joint variation. How do we handle joint variation? But please don't forget to subscribe to the channel. Now, joint variation means there is one variable varying with two or more variables. It means that it can be direct or indirect or inverse proportionality. So here one variable is varying with two or more variables. So we see one variable depends on two or more variables. The moment we start, we have more than two variables, that becomes a joint variation. So let us see the examples in there. Y varies directly as x. So we have y and x, and inversely as z. So those are already three variables. It means that is a joint variation. So how do we handle it? So we start by writing the information. Y varies directly as x. And inversely, so if it's an inverse, it's down. And inversely as z. So inversely means that z is going to be down. As simple as that. Y varies directly as x means this x is up. And inversely means that this z is down to be an inverse. So now, as usual, we remove this k. I mean this alpha minus k. My alpha will be now k x over z. So now we need to know the value of k. So from here I see when y is 2, comma, x is 3, and z is 6. So we put into the formula. So we have 2 equaling to our k into now our 3, the whole over 6, and from there you see that we have, from here we have 2 equaling 2 by this 1 by this 2, k over 2, and from here is that my 2 times 2 will be giving me a value of k if I cross multiply. So that from here now my 4 will be the value of k. Rewriting it again, so my y will be now k, which is 4, now x, the whole over z, which is, this is z. Now, find y when x is 8, when z is 2. So, when x is 8 and z is 2, we want the value of y. So we just substitute. My 4 times x is 8, z is 2, and you see by this 1, by this 2, so we have 2 times 8, and see that my y is going to be 16 with ease. So this one, we have p varies directly as a square of q. They are talking about a square, you underline that. And inversely as a square root, here they are talking about a root of r. So we have p, q, r, those are already three variables, so that one automatically is a joint variation. Then they give you this, whenever they give you this information, is to get the value of the proportionality constant. So we summarize the question. P varies directly as a square of q, a square of q, and inversely meaning it's down as a cube root of r. Simple as that. So you're done with the question. Then they're asking you when p, now we remove this proportionality constant, I mean sign. So my p now will be k q squared over the cube root of r. This is a square because they didn't say square root. This is a root because they say cube root. When p is 4, q is 2, and r is 8. We put in the formula. So 4 will be k into q is 2 squared over cube root of r, which is 8. So this will be 4 equaling to k into, when you square 2, you get 4 over cube root of 8 is 2. And if you cross multiply, from there if you cross multiply, allow me to write here, I'll be having 4 This will be 4 times 2 equaling to 4 times k, which is 4k. So that this will be 8 divided by 4 equaling to k. If I divide by 4 that side, so that my 2 is equaling to k. So after getting the value of k, I'm going to write this. So my p will be now 2q squared over the cube root of r. As simple as that. So now we have only the variables, we don't have any constant. So find p when q is 3, r is 27. So p, they are giving, they want to get the value of p when q is 3, when r is 27. You just substitute in the formula. So my p will be now 2q, which is 3, squared over the cube root of 27. This will be 2 times, this is 9 over the cube root of 3, and the cube root of 27 is 3. So you see, by 3, 1, by 3, 3. So my p will be 2 times 3. And so my p is going to be a 6 with it is. Then we come here, a varies directly as a square root of b, and inversely as a square of c. We write that information. A varies, yes, directly as a square root of b, and inversely meaning is down as a square of c. This is the square root, this is the square. That's the difference. Which is the move for this one? So my a will be k root b, the whole over c squared. Now I want to get the value of a. The ideas are the same. So they are doing when a is 1, b is 9, and c is a 2. We just substitute. A is 1 equaling to k, then square root of b, which is 9 over 2, the c, but it's squared. So my k will be k, this will be square root of 9, this is 3. Then when you square this, you get 4. So this will be now 4 over 3 will be equaling to our k. Rewriting it again from my a to be now k root b over c squared. Rewrite your k. So my k will be the k, which is 4 over 3. Then root b over c squared. As simple as that. Then you start answering the equations. Problem number 1. Find b when a is 3 and c is 1. We want to get the value of b. From here, my a will be 4 over 3 root b over c squared. I want b. So my a is 3, so I have 3 equaling 4 over 3 root b over c squared, which is 1 squared. And this is 1. So if I cross multiply, I'll be having 3 times this, which is 1. So this will give me 3 times 3 equaling 4 root b. So this will be 9 divided by 4 equaling to root b. So how do I get this b? I square both sides. When I square 9, I get 81. When I square 4, I get 16, equaling to my b really is. So here, in Roman numeral 2, they want c when b is 36 and a is a half. You come back from your equation, your a is 4 over 3 root b over c squared. So your a is a half equaling to 4 over 3 root b. So root b is 36 over c squared. So from here, we are going to cross multiply like this. Shall be having this 3 c squared equaling to 2 times 4, then times 6. So instead we can divide 6 squared is going to be, that's 24. And this is going to be 24 times 2, 48. 3. So minus c squared is going to be 48 over 3. And 48 divided by 3, use c squared, I think you get 16. If that is 16, then you get a square root both sides, then the square root of 16, and so that minus c will be a 4 with ease. And so that is the question. This is 16. You got a 1. Focus here, 1. Got 1, 6. Yeah, that's it. So that's it, members. Don't forget to subscribe to the channel. I wish you the best.